In this lecture, we study the transistor biasing. Why we need to apply the biasing? What happens if the biasing is not applied? Now this we have seen already, this is a common emitter configuration. First, how to draw the diagram for this we will see. Now here we are using the positive supply. Generally in electronic circuits, we don't draw loops, input loop like this, output loop like this. So we draw the diagrams differently. How? Let me explain first that, and after that we will see the different types of biasings. Now here we are applying the positive supply. Here also we are applying the one more positive supply. And here we are applying very less voltage, and here we are applying large voltage. Reverse is a large voltage. So instead of purchasing two power supplies and connecting at input and output, by using a single supply, we can redraw this diagram or reconstruct this diagram. How? Now I will show. Now here base, this is the transistor and a common emitter configuration. Base is the input terminal, connector is output terminal, and emitter is a common terminal. Now here input is applied to the positive supply, output is also applied to the positive supply. So instead of that, single supply I can take by connecting like this. Now here to the base, to the supply, one resistor is there, and to the collector, to the supply, one more resistor is there, and both I can connect to one power supply, that is VCC. Now this is how we have to connect the circuit. This is RB and this is RC. So total two resistors we are connecting to the same supply. So no need to use two different supplies. Single supply is sufficient. And in an electronic circuit, we don't show the supply loop like this. Now instead of drawing the diagram like this, so we represent the diagram like this. So here positive terminal is going, so plus VCC and ground. The meaning is what? Battery positive terminal is connected to here and negative is grounded. So no need to show the supply like this. So just if we put like this, then it is sufficient that it is indicating that positive terminal of the battery is going to this terminal and negative is automatically connected to the ground. Now the complete diagram we can draw like this by using the single supply, and so without showing any loops. So this is the diagram. Now here, if we don't apply, now if this is a transistor, so already how the amplifier works, in that we have studied that transistor is an amplifier, in that we have studied that. So if I apply a small voltage at the input, it will give a large voltage at the output. Now if I apply a AC signal at the input, now if I am applying AC signal at the input, it amplifies and gives a large voltage at the output. This is an amplifier circuit. So now for this, if I don't connect any bias, biasing means what? Applying DC at the base to make the transistor on, or to keep the transistor in forward bias at the input side. If I don't apply the DC, then directly if I apply the AC signal like this, then what happens? Now here I am taking one supply over here, okay? Otherwise directly, now just now how I have shown, similarly let me show like that. Now here I am connecting a RC resistor. Now positive supply plus VCC is connected. Now if I if I don't apply any DC for this junction, now this is nothing but what? PN junction. If I don't apply, then this will not conduct, this will not act like a closed switch, and it will not allow the input to the output. Now for this positive half cycle, now the positive cycle is applied. Now this is what? Arrow mark is outside means what? This is the NPN transistor. NPN transistor. When positive half cycle is applied to the P and N junction, then this PN junction is forward biased, thereby what? Output we get the signal. So with the amplification we get the output signal. But if for the negative half cycle, now if negative half cycle is applied, then what happens? Negative is applied to the P, so that's why it is a reverse, this junction is reverse biased, thereby we don't get any signal at the output. With this, what happens? If we are applying the full AC signal, we are getting only half at the output if we are making this input junction forward bias. So thereby what? We are getting the distorted signal. The complete signal is not amplified and we are not getting at the output. That is called the distorted signal. So to get the complete signal with the amplification, we need to apply some DC at the base, and this DC voltage should make this junction always forward bias. That's why we need to apply the DC voltage. Applying DC is called as a biasing. So here we have a different types of biasings are there. How to apply the DC at the base? So by using one simple resistor. Now in the configurations we have studied, by using this base resistor, so we can apply the DC. Now here I am applying the VCC and this is grounded emitter. Now by using this DC, so here some voltage will be available that makes this junction on. This is called the base resistor biasing. And one more method is what? Instead of applying this resistor directly to the supply, now this like this, so we are connecting to the collector. So like this also we can make this junction on. So this is called as the feedback resistor biasing, or collector to base resistor biasing. So this is the second method. And the third one is connecting two resistors like this. So resistor 1, resistor 2. So we are making here, we are grounding here. So resistor 1 and resistor 2 we are connecting to the base now here. So this will act like a voltage divider. What is voltage divider? So whatever the voltage we are applying, so VCC, now here if I try to calculate the VB voltage, VB is equal to VCC divided by R1 plus R2 into R2. Now with this, whatever the voltage will come, this makes this junction on. We have to choose the resistor such that this voltage should make this junction always on. If we keep this on, then what happens? For positive half cycle also it is forward bias. For the negative half cycle also it is forward bias. Thereby at the output we get the two half cycles at the output. This is called the faithful amplification. To get the faithful amplification, we need to apply the biasing. Why we need to apply biasing means what? To get the faithful amplification. And what is biasing? Applying some DC at the base is called the, to make this input junction forward bias is called the biasing. Now this is a voltage divider biasing. So this is a most popular. Why? Because it gives the more stabilized output. Now here by using these two resistors, what happens if you change the transistor or if temperature increases, then the output voltage will not change. Now we have studied the first one base resistor and the second one collector to base resistor. Both stability factor is poor. That's why we go for the voltage divider biasing. Now in the common emitter, in the next topic I will explain the common emitter amplifier, how the common emitter is amplifying the signal, that I will explain in the next topic. For that we need this voltage divider biasing. Okay, so this is about the biasing.